This video is for chapter R.5 from College Algebra. This chapter is a review dealing with factoring. These are topics that you should already have mastered, but it is good review in case you haven't had practice with factoring in a while. On the first page, I've got how to factor in a flowchart. You'll notice anytime you're asked to factor any other polynomial of degree bigger than 1, the very first thing you will always be asked to do is factor out a greatest common factor. No matter how big your polynomial is, you always want to take out that common factor first. So on your lecture notes that I provided to you, in the very top, we're asked to factor out the greatest common factor. In order to find the greatest common factor, you want to find something that's common to all of the terms. In this case, all of the coefficients are even, so I know a 2 is common to all of these terms. So I know at a minimum, I can take out a 2 out of those terms. Also, I want to check to see if there's any variables that they have in common. This has 3 x's, this term has 2, but this term doesn't have any. This is a constant. Since it doesn't have any x's to give, I can't pull an x out in front. So therefore 2 is going to be my common factor. When I pull that 2 out in front, I ask myself, what do I need to put inside so that 2 times what term will bring me to 4x to the third? The answer is 2x to the third. 2 times what next term will bring me to negative 10x squared? The answer is negative 5x squared. 2 times what next term will bring me to 26? The answer is positive 13. So this is what it will look like in complete factored form by just taking out the greatest common factor. So let's look at the next one. There are 2 terms, and they both have an 8 as a coefficient, so I can pull that 8 out in front. Also, they both have an x as a variable. This has 3 x's to take, this only has 2. So at the most, I can take out 2 x's, since this only has 2 to give. So ask yourself, when I distribute this 8x squared inside, 8x squared times what term will bring me to 8x to the third? Clearly you'll need another x. 8x squared times what term will bring me to negative 8x squared? The answer is negative 1. And always check these by distributing. Distribute the 8x squared into both these terms and see if you end up with what you started with. That is a very good way to check your answers. Alright, so now we're going to move on to how to factor an easy trinomial. A trinomial means it has a squared term in front, it has 3 terms altogether. The first term is squared, the second term has an x, but it is to the first power, and the last term is a constant, meaning it has no variable. So all of these are basic trinomials, with the first term having a coefficient of 1. You'll see that there is an invisible 1 out in front of those x squared terms. Now when we factor trinomials with a coefficient of 1, what I recommend you do is to always use the plug and chug method. So if you have a trinomial and the first term has a 1 as the coefficient, in other words a is 1, I would suggest you use the plug and chug method, which means you're basically plugging in numbers until something works, kind of like a reverse FOIL. Okay? So in these terms, I'm going to set it up into 2 binomials that will multiply together to make this term right here. So what you're looking for 2 terms, 2 numbers that will multiply to make 10. So I want 2 numbers, whatever these 2 numbers are, they are going to multiply to make 10. But those same two numbers, these same two numbers, are going to add up to the middle term, which is 7. So ask yourself, what two terms will multiply to make 10, but those same two numbers will add up to 7? And the only combination that will make that come true is 2 and 5. I know 2 times 5 is going to make 10. I know x times x is going to make x squared. So then you play with the signs. Since everything is positive inside, that means everything is positive inside the binomials. And of course you can FOIL this out. X times x is x squared. X times 5 is 5x plus 2x in the middle. That makes 7x. Plus 2 times 5 makes 10. Okay? There's always study tips over here on the right-hand side. In this case, the study tip is to find two numbers whose product is C, in this case 10, and whose sum is B, in this case 7. And that's exactly what we did. Let's try it again. Well, I know the first two terms have to be x and x. That's the only way to create x squared for a first term. The last two terms have to multiply to make 16. So what two numbers will multiply to make 16, but those same two numbers will add up to negative 17? The answer is going to be negative 16 and negative 1. And always check by FOILing. X times x is x squared. X times negative 1 is negative 17x, because you're adding the negative 16x in the middle. And then negative 16 times negative 1 is positive 16. Good. So now we're going to try a different type of factoring, and this is by grouping. We group when you have 4 terms. So when you have 4 terms, grouping is going to be the preferred method there. Grouping is done when there's nothing common to all 4 terms. You'll see that all 4 of these terms have nothing in common. So the only way to factor it is factoring it in groups. Let's look at the first 2 terms by themselves. These first 2 terms have an x squared in common, so I can pull the x squared away from the first 2 terms. The second 2 terms have a positive 2 in common. When I take that positive 2 away from these 2 terms, you're left with x minus 4. Now the whole goal of grouping is to find 2 sets of parentheses that are identical. At this point, if these parentheses are not the same, you've done something wrong, or it's not factorable, and it's prime. The goal is to try to get these to be the same, in which they are, so I'm going to proceed. Since this full term and this full term now have an x minus 4 in common, I can pull that x minus 4 out in front. That leaves me with an x squared plus 2 left over. So this will be the factored form. And of course you can always FOIL this out. Let's try it again. For this group of 4 terms, let's look at these 2 and these 2. The first 2 terms have a 3 and an x in common, so I'm going to pull that 3x out in front. That's going to leave me with x plus 2 left over. The next 2 terms have nothing in common, however they are both negative, so I'm going to pull that negative out in front, so that way I'm left with an x plus 2 inside. If I didn't pull that negative out, then my sets of parentheses wouldn't match. Now that these parentheses match, I can pull the x plus 2 out in front, and that will leave me with a 3x minus 1 left over, and that would be my factored form. Again, always check your tips on the right-hand side. To see if factoring by grouping will work, group the first 2 terms and the last 2 terms and look for a common factor in each group. And that's exactly what we did. Moving on down, we're going to move into trinomials that don't have a 1 as the coefficient in the first term. okay? When you don't have a 1 in the front of a trinomial, in this case it's a 3, it makes things a little bit more complicated. I've got kind of a long process over here to try to help you in doing these, so I'm going to factor this guy using a longer method for the first time, but then once we've mastered it, we can make some shortcuts. So I'm going to factor 3x squared minus 10x minus 8 on this extra sheet of paper. Okay. So what I'm going to do is I'm going to use this method here. So first thing you always want to do is factor out a greatest common factor if you have one. Now these three terms don't have one, so I'm just going to rewrite what I started with, but always try to factor out that common factor first. The next step is to write out what a, b, and c are. In this case, a, b, and c are 3, negative 10, and negative 8. Then calculate what is a times c. A times c is negative 24. So over here, now I'm going to list all of the factors that make a times c. So a times c again is negative 24. So you're going to list out all pairs of integers, two numbers that will multiply together to make negative 24. So for example, positive 1 and negative 24 both multiply to make negative 24. Then we're going to add those two numbers. When I add those two numbers, I get negative 23. The goal is to find a sum that is equal to b. This sum, I want it to be equal to b. Clearly, negative 23 is not negative 10, so no, that one is not going to work. And we're going to continue this table until I find a sum that is equal to negative 10. Don't forget that every pair also has an opposite signed pair. Negative 1 times positive 24 is also negative 24. Those two numbers add up to a positive 23, but unfortunately those don't work also because they don't add up to negative 10. So I'm just going to write down some pairs. I'm going to try 2 and negative 12, negative 2 and positive 12. Those add up to negative 10 and positive 10. Are either of those two numbers equal to b? Yes, negative 10 matches right here. So this is the lucky combination that I want. No matter what other numbers I tried, I could try multiple other numbers. There could have been 3 and 8, 4 and 6. None of those were ever going to work. There's only going to be one possible combination. In this case, the two integers I'm looking for is 2 and negative 12. Once you have those two lucky combination of integers, what I'm going to do next is I'm going to rewrite this original polynomial. I'm going to rewrite it so that way there's two middle terms instead of one. What are two numbers or two terms that will add up to negative 10? 2 and negative 12. So I can create negative 10 by using a positive 2x and a negative 12x. See, those two terms add up to negative 10x. So this polynomial is the exact same polynomial as the one we started with. All I did was split the two middle terms up into, or the one middle term up into two separate ones. Now, based on grouping, which we just learned, I can group these two terms. These two terms have an x in common, and when I pull it out, I'm left with 3x plus 2. These two terms have a 4 in common, but also, since they're both negative, I'm going to pull out a negative 4, which leaves me with a 3x plus 2 inside. And you'll notice these two sets of parentheses are the same. Once you've done that, factor by grouping, that 3x plus 2 can come out in front, and I'm left with x minus 4 left over. So my answer is 3x plus 2 times x minus 4. Always don't forget the greatest common factor. So if you put the greatest common factor out in front, make sure you're plugging it in here in your final answer. We didn't have one in this scenario, but if you had a greatest common factor, make sure you're entering it in front of your final answer. Failing to put this greatest common factor in there when there was one at the very beginning is going to yield a wrong answer. And then always check by foiling this out. So my answer, going back to the lecture notes, for this one right here, was going to be 3x plus 2, x minus 4. So you can see there's quite a bit more work to do in these types of problems with the trinomials when a is not equal to 1. It does take quite a bit more work to do these. Okay? Alright, so let's try doing this one the way we did this one, but I'll try to use a little bit less steps this time. Okay? So in this one, what I'm going to do, the first thing we did is we decided what a times c was. Okay? So a times c is 4 times 15, which is 60. And b is negative 16. So what I'm trying to find are two numbers that will multiply to make 60, but will add up to negative 16. So what are those two numbers that when you multiply them together you get positive 60, but when you add them together you get negative 16. So sometimes this takes quite a bit of thought, and you have to go through a couple different numbers till you find them. But I already found the two numbers because I went through my calculator, and I found that the two numbers that will work are going to be negative 10 and negative 6. Negative 10 times negative 6 is positive 60. Negative 10 plus negative 6 is negative 16. So these are the two numbers I'm going to use. So I'm splitting negative 16 up into negative 10 and negative 6. So then we factor by grouping these two terms and these two terms. These two terms have a 2x in common, so I pull the 2x out and I'm left with 2x minus 5. These two terms, since the first one's negative, I'm going to pull out a negative 3, and that leaves me with 2x minus 5 inside. And it looks good because my parentheses match. Once my parentheses match, I can pull that common factor out in front, and that leaves me with 2x minus 3 left over. And of course, you would check this by foiling. The order in which you write these does not matter. If I chose to write the 2x minus 3 first and the 2x minus 5 second, that's perfectly okay. My math lab does not care about the order of your parentheses. Okay? Alright, next one, number 3. Let's try it again. First thing we look for is a greatest common factor. It turns out I don't see anything that is common to all of these, so I'm going to go through with the a times c process. A times c, in this case 9 times 16, I'm going to have to use my calculator, is 144. B, in this case, is negative 24. So I'm looking for two numbers that multiply to make 144, but add up to negative 24. So what two numbers multiply to make 144, but add up to negative 24? Sometimes, one of the easy things you can check is to see if it's called a perfect square. And we talk about perfect squares over here. A perfect square is exactly half of this number. So 12. Does 12 and 12 work? The same number written twice. And it turns out in this case 12 is a perfect square. If you could see, breaking this down, negative 24 could be written as 12 and 12. And it turns out that negative 12 and negative 12 makes negative 24, but when I multiply them, it actually makes positive 144. So this is actually what's called a perfect square. So when the numbers break down into the identical matches, it's called a perfect square. You'll see what happens as I factor this out. These two terms have a 3x in common, which leaves me with 3x minus 4 inside. These two terms have a 4 in common. Since the first term is negative, I'm going to pull out a negative 4, That leaves me with a 3x minus 4 inside. Since those match, that means my final answer is going to be 3x minus 4 times what's left over, which is 3x minus 4. This is what we call a perfect square because both terms are written twice. And you can simplify this if you want. You could call this 3x minus 4 squared. Okay? Again, don't forget to check your tips on the right side of your lecture notes. So these are now going to be perfect squares. You're going to see down here that some of these are going to be perfect squares just like we did up here. So rather than going through this whole long process, check to see if they're perfect squares first before you do this long process, because this is quite lengthy. This one, I'd like to see if it's a perfect square. I know x times x is going to make x squared, and I know 5 times 5 makes 25. Is there a way I can put my signs in there so that they add up to negative 10? Well, sure. If they're both negative, negative 5 and negative 5 adds up to negative 10. So this is a perfect square. We can rewrite this as x minus 5 squared. Is this a perfect square? We're going to see. What times itself will bring me to 4x squared? 2x times 2x. What times itself will bring me to 1? Well, 1. Is there some way I can put the same sign in here so the two middle terms will add up to 4x? If they're both positive, it will. So my answer is going to be 2x plus 1 squared. Sometimes these perfect squares can be a little tricky. There's nothing wrong with doing it the long method that we did up here. That will also work. It just takes longer to get to your answer. So if you can look for little tricks, if these are perfect squares, it will save you some time. You'll notice in the perfect squares that these two numbers will always multiply to make the last number, but add up to the middle. So you always want to check to see if that will be the case. Okay, move on to the second page. Now we're going to factor the difference of two squares. The formula for difference of two squares is given to you here. So to factor the difference of two squares, the first term has to be something squared, the second term has to be something squared, and there has to be a subtraction in the middle. So when you factor the difference of two terms being squared, you have the first term broken down, you have the second term broken down, and then there will be an opposite of sign in between. They have to be opposite. If they were the same sign, then you'd have a middle term. The reason we don't have a middle term here is because one was positive, one was negative, and that middle term got canceled out. So to factor the difference of these two terms being squared, you can see that this first term is in fact something, in this case x squared. The second term is in fact something squared, and there's a subtraction sign in between. So it does follow the model that we began with. Once you determine that it is in fact the difference of two squares, you can break this down into two binomials. It would be x plus 5 and x minus 5. And of course, you would check this by factoring. Let's try the next one. Always check to see if this is a difference of squares first. Is this term something squared? Well, yes it is. 2x times 2x indeed makes 4x squared. Is this term something squared? I have an error there. 2x squared. There we go. Is this term something squared? It is. It's in fact, it's 1 squared. So since this term can be broken down into something squared, and this term can be broken down into something squared, I can break it down into the difference of two squares. It would be 2x plus 1 and 2x minus 1. Again, opposite signs must occur. In the last one, let's check to see if it's the difference of two squares. What term squared will make 9x squared? 3x. What term squared will make 4? 2. So this will get broken down into 3x plus 2 and 3x minus 2. Check by FOILing. Now the last group of problems we have are to group factor by using the sum or the difference of cubes. So it's very similar to the difference of squares, but this time the terms are going to be cubed instead of squared. Notice that there is a factor for the sum of cubes and the difference of cubes. But up here there's only a formula for difference of squares. So if you had a problem, for example, that was x squared plus 25, so similar to this one, but it was plus 25, that actually would be prime. There is no way to factor the sum of squares. So don't fall for that trick if it's on the test. But the sum and difference of cubes we can factor. You can see that this actually is the difference of cubes. What number cubed will bring me to 8? Well, 2. So this is the difference of cubes. So we're going to follow the difference of cubes formula here to factor. In the first set we have x minus a, so in this case it's x minus 2. In the second set we have x squared, in this case it's x squared, plus a times x, so 2 times x, plus the last term a squared, so 2 squared, which is 4. And you should FOIL this out, or distribute, it wouldn't be FOIL, but you should distribute this out and you'll find you'll actually end up back where you started. In fact, why don't I do that? Let's check it right here. Okay? So let's check this to show you that it works. So what I do to distribute is I take the first term and I distribute it to all 3 terms next door. So x times x squared is x to the 3rd, x times 2x is 2x squared, x times 4 is 4x. Now I move on to this negative 2. Negative 2 times all 3 terms. Negative 2 times x squared is negative 2x squared. Negative 2 times 2x is negative 4x. Negative 2 times 4 is negative 8. And then we combine like terms. X to the 3rd, 2x squared minus 2x squared, well those cancel out. 4x minus 4x, well those cancel out. And all I have left is minus 8. So you can see that this indeed does factor out and FOIL out to what we started with up here. So it does work. Always, always check your answers, especially on an exam. Alright, so a couple more cube problems to do. This time it's the sum of cubes. So let's make sure that it fits the model. X cubed plus what cubed is 125? The answer is 5. And if you don't know what that cubed would be, you can always use your calculator and do the cubed root. For example, on a calculator, we could do the cubed root of 125 is going to bring you to 5. So you could always use your calculator to find those cubed roots. So let's put this into our model. Since we're using the sum formula, we have to use this one this time because it's the sum. So x plus a, x plus 5, x squared, minus, notice the sign change is different, a times x, 5 times x, plus a squared, plus 5 squared, which is 25. Alright, the last one. Is this in fact the sum of 2 cubes? What cubed makes 8x cubed? 2x. Clearly 1 cubed makes 1. So again, this is the sum formula, so we're going to use this top one. So we have x plus a, 2x plus 1, x squared, so it's all of this squared, so it's actually 4x squared, minus ax, so minus 1 times 2x, plus a squared, so plus 1 squared. At the bottom of your lecture notes, sometimes you'll always see some formulas that as a summary of everything you've learned in this chapter. So these are also very helpful to you when doing these. There are some examples here also. So make sure you're going through these examples and following these. A lot of times these formulas are not given to you on an exam, so make sure that you're memorizing these. Anything in these boxes are things that you're going to want to memorize for the exam.